All right, so we're going over the exit problems 4.2. The first one, the first one is actually number 3, so you can find it in your notes. $1,946.25. So I want you to check and make sure that you got it right. Albert, will you take these out? Everybody take off your headphones, AirPods, earbuds, all that jazz. From 4.2. All right, so we're checking our problem and get your 4.2 notes out, Ezra. 4.2 notes out? Okay. All right, I'll come back to this first one for my people who are still digging. I think it's just Ezra. The next one, number 5, should be $58.33. You checking, Savannah? $58.33. Ezra, $58.33. Madeline, come bring your phone up here. Madeline, bring your phone up here. No, ma'am. No, ma'am. You have 2 options. I have somebody come get it, or you're bringing it to put on my desk right now. You know what? I'm just going to keep it to the end of the day.
What? I was putting it down.
You were not. You're walking up here. You stayed on it. We'll talk about it in class.
Yo.
Okay. Number 8, $991.60. Number 1, $10,000. Number 1, $10,000. It's in the back. And then the last one is 3%. Remember, anytime you're finding the rate, once you find the R, you got to multiply it by 100. We're going to go backwards for the people who got theirs out a little bit late. So that was number 1, from backwards. Number 7. Number 5. Number 3. I think that's the last one. Does anybody have any questions on any of these? 3. Number 3. Number 5. Albert, are you checking with me? Are you checking? 8. 1. And 3%. Anybody have any questions on any of these? Got them all right. So I had a bunch of people first period took 0.03, right? Because R equals 0.03, but that's not the interest rate form we're going to give it in. Does that make sense to everyone? This is how much principal, pretty straightforward, solving for P. This one you had to remember, it's the principal plus the interest. You had to find the interest and add it to the principal. So 670 plus the interest. This one was just how much interest. That one was probably the easiest one. That one and this one. How much interest does she owe? Okay. we are going to go ahead and go over the worksheet. You did not check your worksheet yesterday. We're checking it now. Anybody have questions on any of these? Sincere, are you checking your answers, buddy?
No,
Why not?
I already did.
You checked them yesterday? Central? Okay, let's do number 7. All right, it says Marissa deposited $3,000 for 5 years and earned $600 in simple interest. What interest rate did she earn money at? So that means we're looking for the R. Does that part make sense, Chantal? Okay. And the thing we'll want to remember, anytime we're looking for R, once we find R, we're going to multiply it by 100, and then we're going to stick a percent symbol after it. Okay? So here, the deposit is her principal. 5 is her time. 6 is interest. 600 rather. Does that make sense, Chantal? So it says they earned $600 in simple interest. So that's her I. All right, so we're plugging into this formula, I equals P times R times T, where I, we just said, was 600. So we're replacing the I with 600. We're replacing the P with 3,000. Remembering this means time. We don't know the rate, so we're going to stick that at the end. And our time, we're going to replace T with 5 and move the R to the end. Does that make sense? So now we have 600 equals 15,000 times R. So what do we do to solve this equation, Chantal? Yes, what do we divide by? So 600 is not it. So if you right, to 15,000. So whatever's with the variable, Chantal, that's what we divide by, okay? So divide both sides by 15,000. And so now we get R equals 0.04. But for our final answer, it's 0.04 times 100, which is 4, and add the percent symbol. Make sense? Yep. Anybody else have a problem you want to go over? Number 9. Number 9. So number 9 says that Gary deposits $3,700 in an account that pays 2.15% simple interest. He keeps the money in the account for 3 years. If he doesn't make any deposits or withdrawals, what will his final balance be after 3 years? So this is the trick here. Final balance means it's his principal plus the interest, whether he's paying it or whether he's earning it. So let's find the deposit is his principal. The interest rate is 0.0215. That is his time. So we know the principal is $3,700, so it's going to be $3,700 plus some amount. Make sense, Angela? And so now we're going to find our I. We know the P is 3,700. The rate is 0.0215. And we know the time is 3 years. So if we do that on our calculator, I don't know where it is, but I'm going to do it. I think it's $238.65. Is that what you guys got?
Yeah.
Okay. So now it's 3,700 plus 238.65. And so what she has in her account after the 3 years, after she earns this interest, is $3,938.65. It's not a big increase, but at least that's money she earned and by not doing anything except leaving her money in that account. Good. Anybody else? That was from yesterday. Oh no, this is from today. Did you not get it? Anybody else need the notes for today? Okay. If we don't have any other questions on the review worksheet, I'm reminding you that your homework tonight is just the exit ticket, the 4.2 exit ticket in modules. Is everybody clear on that? I'll change the data to that. We have not had time in any class to finish our notes, so I was going to use it in class, but we're just going to wait. It's only 7 problems. So if you have time, after I get as far as I got with the other classes, I'll give you some other class. Make sense? All right, so don't forget, that's your assignment. It's only 7 problems, and it is in Canvas. And the modules in Canvas. Amplify is going to be due Friday, as of right now. I might adjust that to Monday, but depends on how far we get tomorrow, how much we can start tomorrow. Okay? As of right now, I'm expecting that to be done tomorrow night. And again, just to see how many pages we do our notes in class tomorrow. Okay, we're going to go ahead and get started. We've used slope-intercept form before. Today we're going to be writing equations in standard form. The slope-intercept form is a great form, and here it is. Remember, y equals mx plus b. When a linear equation is written in this form, we can see automatically the rate of change, and we can see the initial value or the beginning amount, right? The rate of change is just the slope, right? When we talk about a real-world problem, we talk about it as rate of change instead of slope. That's all. And almost all our problems are based on word problems, real-world problems, right? Standard form allows us not to see any one particular part of that form necessarily, but it does allow us to find the x and y intercepts easily. We're not going to get to that part today. But it also models real-world situations really nicely. And then we could change the form later if we needed the rate of change or we needed the y-intercept. But we're going to do a problem here, and you'll see what I'm talking about. I think it's almost like a sentence, right? Once you, it can describe a situation, a real-world problem, where once you have that equation written, you're like, oh yeah, that's obvious what it means, it's obvious what it represents. We're going to start by talking about Andre's piggy bank. He gets paid $5 a week for his allowance and $10 every time he mows his neighbor's yard. He puts all his money into his piggy bank, and his piggy bank contains $70, but it only has $5 and $10 bills. Okay? If there are no $10 bills in his piggy bank, how many $5 bills would there be in there? 14. How'd you get 14? 70 divided by 5 gives us 14 $5 bills. How many $10 bills are there if there are no $5 bills? Yep, and it's 70 divided by 10, right? The total money is divided by the amount of money the $10 bill is worth, and that equals 7. So 7 $10 bills. 70 divided by 10. Are you asking me a question, Liz? Okay. Number 3 says, Rebecca guessed the piggy bank contains $5 bills. Have you ever looked at something and like, ooh, how many jelly beans are in a jar? How many red jelly beans are in the jar, right? So Rebecca's guessing that this piggy bank contains $5 bills. Is there any way she's right? would $5 bills be worth? $25. That makes sense. How much money is left? If there are $5 bills and all the rest are $45, right? Can you get $45 out of just $10 bills? Yeah. So $45 is not a multiple of 10, so we can't have $5 bills, right? Our fives would have to be in even numbers, so we could get multiples of 10. How would you solve for the number of $10 bills if there are exactly 8 $5 bills in the piggy bank? What would you do? Yeah. So if we want to know how many $10 bills there are, we know there's 8 $5 bills, we're going to figure out how much money those $5 bills are worth. So 8 times $5, because each $5 bill is worth $5, right, is equal to $40. We subtract that from the total in the piggy bank, and now we know there's $30. If we divide that by 3, then we know that there are 3 $10 bills in there. It looks like it's minus there. I'm trying to work that out. No. There's 3 $10 bills. Could you write an equation using variables, so we're not going to plug in any numbers? Well, we're going to plug in some numbers, but not all the numbers. Can anybody just, looking at this visually, could you think of an equation you would like to write?
Minus plus 10 minus equal to 6.
Exactly right. So what does 5x, what does the 5x represent in this equation? Not the number of bills, right? 5 times x represents what? X, not the number of $5 bills. X represents the number of $5 bills, right? What did you say, Divya?
Variable?
Not the variable. The amount the $5 bills are worth in the piggy bank, right? 5 times the number of $5 bills would tell us how much money in $5 bills is in there. And so then 10 times the number of $10 bills would tell us how much money in $10 bills is there. And we know that that is the total amount of money in there. So now that we know, it kind of makes sense, right? It makes sense that it's kind of almost a visual explanation of this problem. So we're going to be using this format to write equations in almost in standard form. All right, so this is standard form. AX plus BY equals C, where X and Y are variables and A, B, and C are integer constants. What is an integer? You guys remember? It is a number. Well, sorry? Don't be shy. If you think you know, say it. Who cares if you don't remember? It's a vocab word. Well, I'll remind you. What do you think it is, Leda? Oh, you're thinking of like a rational number. Yeah, it is a rational number, but it's more specific. The groups of numbers, integers, whole numbers, natural. You have to harken back to your 7th grade year, right? An integer means, so we use integers a lot in algebra, so you should, an integer means no fraction or decimal, right? It can be positive or negative though, right? So this can be a positive or negative, no fractions or decimals. Why is that so fast? Alright, so positive or negative number, no fractions or decimals. There's another criteria, and we'll talk about that in a minute. So looking at this standard form formula, A, X means A times X, right? BY means B times Y, and C is equal to C. And that's not going to change. It's going to be C for constant. C is the constant. All right? It doesn't change. Now, this term's value could change. This term's value could change depending on what we plug in for X and Y. Right? So, in this equation, can you tell me what the A A, the B, and the C would be?
A equal to C. B equal to 5, C equal to
It is. We're going to practice raising our hands. Yes, you're right. Okay, so next time raise your hand when we call on you. Okay? But you're exactly right. The next one is a little bit trickier. Remember this part here we said it could be positive or negative or positive, right? The negative or positive. So what do you think the A, the B, and the C are here? Don't put it out. What's the A? Chantal? Say it again. A is 4. What's the B going to be? Think of what the B would be. So the B is the hardest one. What do you think, Zariah? Is it 7? Minus 7. Is that a positive 7 or a negative 7? Yeah, that's the tricky part. You got to look for that operation. That operation tells you if that coefficient is going to be positive or negative, right? And then what is our C telling me? Yes. So if we know our A, B, and our C, we can write an equation to fill in these blanks. Yes, you do.
4x plus 2y equal to something.
4x?
So 2y equal to
Yes, it's equal to 24. So we're just filling in the blanks here. Everybody do this one on your own. Remember the tricky part is the negative. So everybody's doing this. No one's saying it out loud. Deanna, did you do this one already? Okay. What'd you get, Deanna? Perfect. Now, you might have plugged in here, so she's right, and this is the form we wanted in. You might have plugged in 3x plus negative 2y equals 18. Not technically wrong. From there, though, we do want to change it to minus 2y equals 18. Does that make sense to everyone? All right. So, we talked about Andre's piggy bank, and we've talked about a lot of this already. But in this equation that we wrote for about to represent the amount of money in Andre's piggy bank, what does the x represent here? What does the x mean? Well, first let's think about what does the 5 mean? What does the 5 represent? Perfectly said, the value of one $5 bill. And so then the 10 represents the value of one $10 bill. Right. So then what do you think the x and the y represent?
Yeah, Aiden Williams.
Aiden? I have an A. Well, I normally have an Adrian, but she's not here today.
Is her last name Williams?
I'm pretty sure it is. No other first name. Not there. Yeah, it's Adrian Williams, but she's not here.
Okay.
Right.
Thank you.
Okay. So if 5 represents the amount of money that each $5 bill is, and 10 is the value of each $10 bill, what do you think x represents? Yes, the number of $5 bills. And then y would represent the number of $10 bills. So then A, and B, and C. What's A? Yep. What's B? And what's C? So the value of these terms can change. This one is always going to be the total. It's not going to change, right? The C. So this is going to be the value of all the $5 bills on online. The value, we're not going to write it, but we already talked about it. So y'all should know. So that's the number for each $5 bill, the amount of money for each $10 bill, or value of each $10 bill, and this would be the total money. The numbers are not money, right? But all 3 other numbers represent money in this case. It's not always that way in the standard form equation, right? But we talk mostly about money in here. All right. So we're going to use kind of that same information. We're going to for Jose going to a minor league baseball game with friends. During the 7th inning stretch, they go to the concession stand. Hot dogs are $2 and nachos are $5. They spend $20 in snacks and head back to watch the game. Write an equation to match the total cost. So, usually the easiest part is the total cost. Does anybody know what the total cost is already? $20, right? So the total cost is going to be the C, right? It's going to be equal to that. So we already know what part of our equation is going to be. Does that make sense? So the total cost is made up of the amount of money we spend on hot dogs and the amount of money we spend on nachos. If you agree, add it together, and that gives us our $70 that they spent. So, but we need to write our equation with some number times x plus some number times y, and it's going to equal $20. So, what do you think? I don't know how it comes to everybody's mind differently, right? Maybe you look at this and you already know the equation, and then you go back and figure out what the parts are, right? This is pretty straightforward, right? It's good to figure out, if you know how to do that, does anybody know the equation without owning the parts? No? Do you know?
2x plus 5y is equal to 20.
So 2x plus 5y is equal to 20. That's right. So then the question is, sometimes that makes sense to you, but do you know what the x represents? Do you know what the 2 means? Right? Do we know what this term means? So what is this term? What is this term, right? So based on this, too, we should know what this term represents, right? Because we're talking about a total amount of money spent, right? So if 2 is the a, and it is, what does the x represent? This is the hardest part, defining the variable sometimes. If you can define the variable, it's really better if you can define the variable at the beginning, but sometimes you can work your way backwards and figure that out, right? So what does this variable represent? How many hot dogs are? This represents what you said, Chantal. This represents how much each hot dog costs. This represents how many hot dogs we buy. So then what does y represent? Right? Okay. How many, the number of nachos, right? And so a is 2, we've already said, and the only number we have left is 5. So reading this problem and then seeing this equation, you can kind of pick out what the parts represent, right? Yeah. You could write it that way. It technically wouldn't say it in standard form, we would switch it around. So could you write it, 20 equals 2x plus 5y. You could, but we're working towards the total cost, so we want to work it left to right. Okay? That does mean the same thing, though. All right, so we're going to make sure we get these two problems in. If we get these two problems in, then I'll let you start on your exit ticket for 4.2. You're going to be a little bit ahead of the game. Betty uses 2 eggs to make brownies, 3 eggs to make a cake, and 6 eggs to make a souffle. In all, she has 1 gross of eggs, and 1 gross is 144. Already a confusing concept for some people, so I don't know why we introduced gross here, but a gross is like a dozen, so a dozen eggs is how many?
12.
12. So a gross of eggs, thank gosh they told us because I did not know a gross of eggs was 144, right? That's all we need to know. So we're just talking about 144 eggs here. So they let us know how many eggs to make brownies, how many eggs to make a cake, and how many eggs to make a souffle. And then they tell us she only wants to make brownies and souffle. And she uses all of her eggs. Write an equation to model the eggs used by Betty. So for me, when I'm doing this, I'm like, okay, that sounds like a hot mess. They use this word I don't know. Okay, I figured out what that word is. So now I'm going to make myself a little mess. I'm going to use, she uses 2 eggs for brownies. Everything's about the eggs, so I'm not even going to write the word egg. and she uses 6 eggs for souffle. Does that make sense to everyone? So she makes 1 pan of brownies, Ezra. So that's open your eyes. She uses 2 brownies. If she makes 1 souffle, she uses 6 eggs, right? If she makes 3 pans of brownies, how many eggs will she use? 3 pans of brownies, how many eggs will she use? 6, yeah, just 3. If she makes 2 souffles, how many eggs will she use? 6. Okay. So let's start with what we said is usually the easy part. And so we know that our equation is going to be equal to C. That's going to be the total. In this case, it's going to be the total eggs. What are the total eggs Betty's going to use? 144, right? So we know we need an A, we need AX plus BY equals C, but we just said that's 144. So far, so good? So we have some other numbers in here, right? What do you think the A and the B are? What do you think the A and the B are, Cynthia? I didn't ask him. I asked you. Look up here. What do you think the A and the B are? What are the other numbers are you? Yeah, that's right. Hey, you know what? Not he knows it, but you also know it. He is. You need to go on a roll too, and you are now. Look at that. 2 and 6. What? Yeah. All right, but so we could put 2 and 6 here, but what does the X represent? What does the Y represent? Yeah?
X is the number of brownie and Y is the number of soup.
That's exactly right.
Okay.
All right. So if they gave us this equation, 2 times X plus 6 times Y is 144, we should be able to say, if they ask us how many cakes they make, we're going to go, no cakes. They didn't make any cakes, right? Because the cakes required
I got a question.
3 eggs.
Why would you use 3?
Because we didn't make any cakes. You gotta read the whole problem. She only makes brownies and souffles. That's why here we only wrote the 2 brownies and 6 souffles. They gave us more information than we needed.
That's why I could have.
That's okay. At least you had a reason. We didn't use the 3 because we didn't make any cakes.
I have 3.
So let me ask you this: if we made cakes and souffles, what would our equation be? Equals. Yeah. So this would change because then this would be the term that represents the number of eggs we use for cakes, right? If we made cakes and brownies, what would that equation be? Yep, 2x plus 3y. 2 eggs to make a brownie, 3 eggs to make a cake, 2x plus 3y still going to equal our total. Now technically, this is not in standard form. Anybody remember from algebra, what are we going to do to this equation to get it in standard form? Yes, what are we going to divide by, Shintra? Yes, we've got a common factor of 2.
Let's go, Chantel.
So be x plus 3y equals 72. But we're really going to use this equation. So we are using standard form in a way, but we don't have to use it exactly standard form. This is very descriptive of that problem, don't you think? It's a visual almost of that problem. So let's look at this one. Very much collecting things. Pay attention to what we're using and what we're not using here since here. On average, he pays $1 per postcard, $4 per figurine, and $12 per hat. Write an equation the total cost of his collection if he spent $88 on just hats and figurines.
That's the sum 88 at the end, right?
Yes, there we go. The sum is 88. What is he not going to spend money on this year? Postcards, that's right. Scratching the postcards. So I'm going to write here if he's buying hats and figurines, it's $12 per hat and it's $4 per figurine. You'd be surprised how much it helps just writing little things like this down. So we should go ahead and probably write this equation at this point. Kate, can you tell me what the equation is without us knowing what x and y are?
4x plus 21.
Let's go.
And you can swap it. So Kate used x for figurines and y for hats. I already have it the other way, but it would not be wrong the way Kate said it. Does that make sense, Kate? I'll prove that's not on this way, but okay. Oh, yeah. So x is the number of hats, y is the number of figurines. So 12x represents what? What does 12x represent here? So the number of hats times the cost for each hat, so it's the total cost for all the hats you bought, right? And then for y would be the total cost for all the figurines you bought, okay? Yes.
So could I wrote 4 again?
Yes.
You could?
Yeah. If you define x as figurines, you could say 4x plus 12y. Yes. So you feel like everyone do it. I didn't actually write it this way. Somebody else wrote it down. I just used it. And it doesn't matter. One is not any more right than the others are right. So for me, I thought of the one that came. I think the reason why they wrote it is hats came first here, and figurines came first in this problem. I think that's the only reason why. When it asked you to write the equation, they had hats first and figurines first. But it does not have it. Okay. So we're not going to finish these yet. We're going to finish them tomorrow. Right now you have time. You can work on your 4.2 exit ticket. If you did not submit your worksheet or your 4.2 notes, please go and do that now. Remember, we're working on the second quarter grades now. We're going to start off not in the hole. We'll start off with 100. No, we'll just put that here and put your phone in the box and use the charger.
I got the charger.
Okay, this cable, there's a, put that just right there since you have the charger. Yes, hurry up. Oh, let me stop my recording.